Hello everyone, welcome to my class on computer graphics. I am Shravani Kundu, Assistant Professor, Department of Computer Science and Engineering, Guru Nanak Institute of Technology. Today I will discuss two-dimensional viewing and clipping of an image. So the overview of this lecture is, here we will discuss how to view the object in our world coordinate system and corresponding the device coordinate system. Along with that, how to clip that object based on the reference frame where we want to view the object. After learning this lecture, after going through this lecture, students will be able to understand the basic concept of the two-dimensional viewing, and along with that they can transform any object from the world coordinate system to the viewport. So far we consider the formal mechanism for displaying viewing of a picture on an output device. So typically the graphics package allows a user to specify which part of a defined picture is to be displayed and where that part is to be placed on the display device. So any convenient Cartesian coordinate system referred to as the world coordinate reference frame. So that indicates that what we see around us, that means what we can see, whatever the object we can see around ourselves, so those object belongs to the world coordinate system. Rather, you can say that if I want to identify the position of any object, we basically have to know the latitude and longitude of that object. So here latitude and longitude is used as a coordinate system, and which is used to identify the position or location of the object. Now, while we can see any scene through our eyes, then all the objects present in that scene has its own position. Now, while we want to map that picture, that means while we want to project that picture to the display device, it may be TV screen, it may be camera, or it may be something else, some display device. So if I want to display the image through some other display device, then that coordinate system where the picture will be mapped, that coordinate system is called the device coordinate. So basically there are two types of coordinate system: the image, the object which we can see, the location and or the position of each object in our surrounding has the coordinate system, and that coordinate system is called the world coordinate system. So basically the world coordinate system describes the coordinates of the picture. Now while we want to project that picture through the display device, then the coordinate of the display, then the position of the object in that picture will be guided by the coordinate of the display device. So this type of coordinate is called the display device coordinate system. And the important thing is that while we want to project the image from any image from its nature to the display device, then we have to transfer the coordinate from the world coordinate system to the display device coordinate system. So far here you can see that, so consider the latitude and longitude of this image. So the position of the image, so it starts from the 36 degree, and it is something around let us say 37 degree, and again this position is suppose 18, and this is say 19 degree. So these identify the position of the image. But while we will project this image through the display device has its own coordinate system. So let us say that this display device has some x coordinate. So this along this direction, this is x, and along this direction, this is y. So this location basically starts from 0, 0. So this is the origin. And suppose this ends with the 1024. So that means the number of pixels along x direction is 1024 and the number of pixels along y directions maybe suppose 800. So here you can see this entire picture. So maybe the location of this object, maybe the location of this object is something, let us say this is 38. So we can say this is 37 and 18.5 is the location of this particular object. So when this object will be mapped in the display device, so this the location of this particular object will change, and maybe and consider the location of this object is 500, 400. Okay, so you can see the coordinate is changed. So this image belongs to the world coordinate system and this image belongs to the device coordinate system. So in the world coordinate system, the location of this object was 37 degree and 18.5 degree. But while we move this, while we will project this image through our display device, then the coordinate is changed from 37 18.5 degree to 500, 400. So in this way, so this is the main focus, that how we can change the world coordinate system to the how we can change the world coordinate system of an image to the display coordinate, the coordinate system according to the display device, so that we can display the image through the device. Okay, so now the next thing which I will show you, that how we can change this coordinate device, how we can change the coordinate system, and what will be the corresponding equation. So let us say, consider this is a port, this is a window. This is a window of the world coordinate system. And similarly, this is a window of the display device. Okay, so this is the area of the display device and this is the area of the world coordinate system. Fine. So let us say there are some x-axis. So we will draw the coordinates axes. Similarly, here also we will draw the axes. Okay, so here you can see that this is my x and this is our y axis. This is also x and y axis. Fine. So here you can see that, consider there is a point P in this location. So this is the location of a point P. Now this is the point, the point P is in the world coordinate system. That means here the port, the image which will be shown through the world coordinate system, we will say that the area is the window. So here this is called this is our window port. So window port basically project the image through the world image by using the world coordinate system, and this is called the viewport. So viewport basically display the image by using the device coordinate system. So basically, so there are two ports, one is the window port and another is viewport. So we will now tell this port as a window port and we will tell this one as a viewport. So consider there is a point P which belongs to the window port and we want to display the same point P in the viewport. Now the thing is that while we will project the point P from this window port to viewport, the respective location of the point P, that means the location position of the point P with respect to x-axis and with respect to y-axis will not change. It will remain same. Okay. So that means the displacement of the point P from the horizontal and vertical frame of the viewport will remain same as the window port. So what we have to do? We have to just scale the image. That means here you can see the length and breadth of the port. If you compare the length and breadth of the window port and viewport, you can see the length and breadth of the viewport is smaller compared to the window port. That means we have to scale down the coordinate while we will transfer the point, any coordinate, any object from the window port to viewport. Okay. So let us say this point. So this is called the XW mean. So XW mean is the smallest coordinate of the window port, and this is the XW max. So XW max is the smallest coordinate along x-axis for the window port. Now here also we can say this is our YW max and this is our YW mean. Okay. So mean and max represent the minimum and maximum Y value for the window port. Now in the viewport also, this is represented by XV mean. So this is the minimum X mean and this is the X max along the X axis. Okay. So X mean, XV mean and XV max is the minimum and maximum X value of the viewport. Similarly, YV max and YV mean is the minimum and maximum Y value of the viewport. So you can see that this point P, let us say this point P is L unit away from the XW mean and this is M unit away from the YW mean. So there must be a ratio L by M, and while we will project the point P in the location, let us say this is P dash. So while we will project the point P in the position P dash, so say this point P dash is Q unit away from the XV mean and R unit away from the YV mean. Fine. So this ratio should be same as this Q by R. So if we maintain the same ratio, that means the ratio along which the P is away from the minimum and maximum XY value, in the same ratio the P dash will be away from the minimum and maximum XY value of the viewport. So if I can maintain that same ratio, then we can project the object in the same position in the viewport. Okay. So how we can maintain the same ratio? This ratio can be maintained just by performing the scaling. That means with the L value, we have to multiply some unit. So this unit called the Sx, it is called the scaling factor. So we have to multiply some scaling factor Sx with L so that it will produce the value Q. Similarly, if I multiply some Sy unit with M, we can produce the R. So what is our objective? Our objective is we have to find out the value of Sx and Sy. Fine. So now you can see that in this case, so what is the point? So let us say the point of P over here is XW, YW. and the point of P dash is xv comma yv. Fine. So what we have to do? We have to find out the xv and yv. So what you can see, if I find out the same ratio, okay. So what is the distance between this? What is the value of q? The value of q is nothing but xv minus xv mean. So this is the value of the q. You can say this is xv, this distance is xv, this is xv. Then what is the value of q? The value of q is xv minus xv. And this one should be, we will have to maintain the same ratio. So what is the value of L? Okay, okay. Before that, we will find out this ratio with respect to how, our objective is how to find out this Sx. Okay. So what we can do, we will find out the ratio, this one, by dividing it with xv max. That means xv max minus xv min. That means this unit is how much proportion, that means the q contribute how much percentage of this total length of this total length of the viewport. Okay, so what we are finding by this ratio, with the help of this ratio, we are finding that this q contribute how much proportion of the total length. Similarly, so that should be equals. Okay, so this one should be equal to this L divided by this total one. Okay, so what is my L? We can write L is xw minus xw min divided by what is the total unit? The reference frame is xw max minus xw min. Okay, so from this equation, what we can get? From this equation, you can get that this xw max minus xw min. Okay, so what we can derive like that, we can derive it is like xv is equals to first we'll write it like that. Okay, let me write it. Xv minus xv min is equals to xw minus xw min, this one, into, we can write it like that, xv max minus xv min divided by xw max minus xw min. Okay, so if I write so we can say that this portion, so this one, this is my scaling factor Sx. Okay, so if this is my scaling factor Sx, then we can write xv is equals to xv min plus xw minus xw min into Sx. Okay, so in this way we know the max min value of window port and viewport. So by using those max min value of the window port and viewport, we can find out the Sx. In the world coordinates, we know the value position of the xw and yw. So by using the value of the xw mean, and by using the xv mean, we can find out the relative position of the xv for the point p dash. So similarly, if you go for the y direction also, you also can find out by doing the same equation, by deriving the same equation, you also can find that yv is equals to yv mean plus yw minus, so if you derive this in the same way, sy. So what is our sy? Here you can see that after derivation you will get the sy like this one, yv max minus yv mean divided by yw max minus yw mean. Okay. So in this way, you can derive the SY also. So once you know SY and SX, then you can easily convert the points from the window port to the viewport. Okay. So this is the way to conversion of any image which we can see in our window port. We can convert this image. If I want to display the same image through our display device, so we have to convert each and every coordinate of that image by using this equation, and then we can get the relative points of the same points which is in the window port. We can get the xy value for the same point in the viewport also, and then we can construct the image in our display device. Okay, so this is called the window port to viewport transformation. Clear? Now next we will discuss another important topic which is called the clipping. So while you can see that you always all of us use the very common features which is called the crop. So we have some image, we have our own image, we want to only crop our face part and we want to eliminate the other things. So we use the cropping tool, and by using the cropping tool we can select a particular position of the image and we can discard the other part. So the area, the region which we want to focus, that means the region only where I want to display the image, that region is called the clip window. So here you can see this is our original image. Now we want to focus on these two houses. So so you can see there is an area which we want to view, and this area is marked by the red color. So there is some rectangular area, and we want to display only this part and we want to discard the rest of the things from the image. So if I want to display only that particular part of the image, and after discarding, our clipped image will look like this one. Okay, so this is the main objective of the clipping. Clear? So why we should do the clipping? The objective of the clipping is to discard the part which we don't want to display, and we will focus only some proportion of the image and where we need to perform some operation. And the region where we have to focus, that means the portion of the image which we want to keep, that portion of the image or that region is called the clip window. Okay, so now we will see how the clipping operation we can perform. So basically there are different types of clippings are there. They are called the point clipping, line clipping, area clipping, curve clipping, and text clipping. So now we will discuss the point clipping. So point clipping is very easy. So you know that you have the clip window, you have a point, you can check whether the point is inside the window or not. Okay, so now we will discuss the point clipping. So let us say we have this window. Okay, and we have some points around this window. So let us say there is some points like this one. Those are the points which are placed around the image. Some points are there, discrete points, and we want to clip this region, the region shown by the rectangle, red colored rectangle. So this is my clip window. So this is my clip window, and we only want to focus only those portion of the image which is present inside this window. So here that means this entire image has some points, but as we want to crop only this particular position, so we have to keep only those points which is inside this rectangle. So let us say the size, that means the dimension of the window is something like this is x min, this is x max, and this value is y min, this is y max. Let us say this. So the different dimension, this is x min, this is x max, this is y min and y max. So while you have a, so we have a, suppose this is a point P1 and this is another point P2. Okay, so what we want to check, we want to check whether the P1 is present inside the clip window or not. So how we can check? It is very simple. For the point P1 there is some coordinate x1 and y1, and for the point P2 the coordinate is x2, y2. So what we have to check, we will check whether the x1 belongs to the x min and x max and y1 belongs to the y min and y max. If both conditions are true, in that case P1 is inside, otherwise P1 is outside. So here you can see this. So what will be our condition for checking the position of the points? So we will check the if x is greater than equals to x min and less than equals to x max, and y is greater than equals to y min and less than equals to y max, in that case the point P is, if it is true, that means if this is true, in that case it is inside, else outside. Okay, so here you can see, so if you consider this x1, so definitely x1 is between x min and x max, but once you consider y1 is greater than y max, so this condition is not satisfied, that means it is outside. But if while you will consider the point P2, so P2 has x2 and y2, so x2 is again between x min and x max, and y2 is also between y min and y max. So this condition, if statement is satisfied, so the point P2 is inside the clip window. So in this way we can check whether a point is present inside the clip window or not. So this is the condition for point clipping. So as I told you that there are different clipping algorithm we will discuss. So the number one is the point clipping. So you can check the position of the points, whether the point is inside or outside of the clip window, by using this particular section of code. Okay. Now there is another type of clipping where we will check for the line. So this is called the line clipping algorithms. So in the line clipping algorithm, we will check whether the line is present totally outside of the clip window or totally inside of the clip window, or some portion of the line segment belongs to the clip window. Okay, so this is the line clipping algorithm. So now we will discuss the line clipping algorithm. So consider Consider a window like this one. Okay. And this is our clip window, and there are some lines. So those lines are something somewhere like here. So some lines are here, some lines are here, someone is here, okay, and someone is here, and some lines are here. So there are different types of lines. Now, what we have to do, we have to check whether we have to clip the line. So once you will clip the line segment, so after clipping, so this is our entire image, and after performing the clipping operation, so if you clip it, so after performing the clipping operation, the output will be something like this one. So this will be your clipped image. Okay, so for this particular image, the clipped image will be this one. So where we can, inside the clip window, we can see only this line segment and this portion of the line segment, and rest of the things we will discard. Fine. So let us say this is the point P1. For this particular line segment L1, the line points are P1, P2. For this line segment, this is P3, P4. For this line segment, this is P5, P6. For this line segment, this is P7, P8. And for this line segment, this is P9 and P10. So there are 5 line segments, and among the 5 line segments, only one line, that is which is constructed by P1 and P2, that line segment is totally inside, and the line, some portion of the line P3, P4, that means some portion, intersected portion of the line P3, P4, which is intersected by the clip window, that portion is inside the clipping window, and rest of the lines are outside. That means after clipping the entire image, we will get this one as our final output. So this is our output. After performing the clipping operation on this entire image for this particular clip window, our final output will be this one. Okay. So now how we can perform the clipping? So point clipping, you can see it is very easy. We are just comparing the minimum maximum value of the points and we can take the decision. But for window clipping, the concept is something different. Okay. So what we have to do over here? So here we will first, there are different types of line clipping algorithm. The first line clipping algorithm which we will discuss is called the Cohen-Sutherland line clipping algorithm. So I am writing it, Cohen-Sutherland line clipping algorithm. Line clipping algorithm. Okay, so this algorithm we will learn now. So for the Cohen-Sutherland line clipping algorithm, so what is the logic is that here we will generate the region code. Now to generate the region code, what we have to do, the entire viewport, that means the clip window. So this entire clip window is divided into some regions. So here you can see I am dividing it into some regions. I am extending the line by dotted one, and I am dividing this entire clip window in some region. Okay. So you can see there is total 9 regions. So this is region 1, 2, 3, 4, 5, 6, 7, 8, 9. So total 9 region. So what we will do, we will generate the region 9 region code. So for each region, we will generate some code. And the region, the middle one is the region which is inside the clip window. So that means whatever the object whatever the lines will belongs inside this middle one, so only we can see only that one, and the rest of the things we will discard it. Okay, so what we will do, the Quinn-Sutherland line clipping algorithm is called the based on the region code. So this is called the region code. How we can generate the region code? So this region code is generated by 4 bit. So this is 4 bits region code. Now this is the bit position 1. This is the first bit, second bit, third bit, and fourth bit. So 4 bits are there. So bit position 1 indicate the left. Okay. Bit position 2 indicate the right. I am writing R. Bit position 3, R stands for right. Bit position 3 indicate the below. So I am writing B for below, and bit position 4 indicates the above. Okay, that means if the line segment, if the point is above the lines, so that will be indicated by the position 4. Okay, so this is the left side. This is the, what is left, right, below, above? The left is the left side of the clip window. R is the right side of the clip window. So here, this is the left side. So this one is our left side of the clip window. This is our right side of the clip window. This is our below side, below of the clip window, and this is the above of the clip window. Okay, left, right, below, and above. Now, here we will generate the region code for each region based on the position of the left, whether that region is in the left side of the clip window or in the above of the clip window or right side. So based on the position of the region with respect to the clip window, we will generate the region code. Clear? So each region has 4 bits. Now you can see, so I am just writing it for your easy reference purpose. A, B, above, below, right, and left. Okay. So you can see this region, this particular region. So this region is left side of the clip window. So this is the left side. So if it is left side of the clip window, we have to write down 1. Is it the right side of the clip window? Definitely not. Once it is left, it cannot be right. So we will write it 0. It is below? No, it is not below. We will write it 0. And it is above? Yes, it is above. So we will write it 1. Okay. So in this way, using the Quinn-Sutherland line clipping algorithm, we can generate the different region code. So you can also generate the region code for this particular region. So this is the left side of the region. Yes. So the region code will be 1. It is the right side. No, 0. It is the above of the clip window. No, it is not the above. It is below of the clip window. No, it is not below. So region code for this particular section is 0001. Again, for this particular section, it is left side. Yes, it is left side. It is right side. No, 0. It is below. Yes, it is below. So we will write down 1. It is above. No, it is not above. So we will write down 0. So it is 0, 1, 0, 1. Again, for this particular region, so it is left side. No, it is not left side. It is right side. No, it is not right side. It is below. Yes, it is below, and it is not above. So the region code is 0100. Now, for this particular section, what will be the region code? It is left side. No, it is not left side. It is right side. Yes, it is right side. It is below. Yes, it is below. It is above. No, it is not above. So 0110 is the region code for this particular section. Again, for that region, what will be the region code? It is left. No, it is not left. It is right. Yes, it is right. Not below, not above. So the region code is 0010. Again, for this particular region, it is left. No, it is not left. It is right. Fine. It is below. No, it is not below, but it is above. So it is 1010. And here the region code will be, it is not left, not right, not below, only above. So the region code is 100. So you can see that for this particular clip window, we have generated 8 region codes like this one. Okay, so there are 8 region codes. So those are the region codes. 8 region codes you can see. Okay. And the region code for the inside of the clip window, what will be? It is not left, not right, not below, not above. So the region code will be 000040. Okay. So this is all about the region code generation of the Cohen-Sutherland line clipping algorithm.